Finally, the reduction of alkynes. So you can have a complete or partial reduction. What do I mean by this? Well, if I have this right here, this alkyne with an excess amount of H2, then this will simply give me back to the alkane. So this is a complete reduction. But this may not be useful because alkenes are fantastic. Alkenes are fantastic starting materials. So what can we do? Well, you can have a partial reduction and you have two choices. Okay. By the way, before I begin again, if you have this, like that, and you say, and it says H2, then again, you just show completely an alkane. So you have 1, 2, 3, 4, 5, and 6. So you just draw a hexane, I mean. 4, 5, 6. You want to show the H's, you can, but there's no need. We know the H's are there. Now, here are two ways. You can make using Lindlar's catalyst and H2, you can make the cis isomer, and I write it here, and here's Lindlar's catalyst. It's lead or palladium with calcium carbonate and quinoline. This is a catalyst that's used for this purpose. We're not going to learn the mechanism because it's complicated, but what you would produce is you would produce the cis isomer. So you need to think of the cis isomer for this. So it would be obviously this, where both of these two groups are on the same side. So this is cis. The H's are on the same side. And of course, the two alkyl groups are on the same side. And of course, if you use sodium metal, sometimes lithium metal, and liquid ammonia at -78 degrees Celsius, very, very cold, you actually can produce the trans isomer. So this is trans, once again, opposite sides. Which I say, these are the reactions right here. So be aware that, again, liquid ammonia, sodium metal give you the trans, and of course, Lindlar's catalyst gives you the cis. So how would you show these? You might be asking, how do I show these using skeletal structures? So let's actually look at that one. H2 and Lindlar's catalyst. We're just going to say Lindlar's catalyst. We're not going to draw the whole thing, the whole reagent. Okay, so how do you show this? Okay, very good. That's a very important thing. So again, 1, 2, 3, 4, 5, and 6. You need to make sure that both groups, whatever you have, on 3 and 4, like this group and that group are either up or they're both down. Up or both down. So let's begin. So let's say we have this right here. So you have one, two, three. One second, it's not letting me. And watch. So you have 1, 2, 3, 4, 5, and 6. Or what I wanted to say was, remember the E and the Z? So you have a double bond right there, and then you put both groups, again, either up, just like that, or you can put them both down. Right there. Now, if you have the trans, then you can leave it the way it is. Not the way it is here. I'm saying this, you can leave it as, if you have 6, if you leave it like that, then that's automatically the trans isomer. 1, 2, 3, 4, 5, and 6. Trans, they're both on opposite sides. So that's it for synthesis. Be sure you're very knowledgeable with these reactions. Review them as much as you can, because when you come back, when we meet, we will go over synthesis, which requires you to know the reactions of of alkenes and alkynes, and we put them together to actually use to build one target molecule like we have right here. So again, be sure you're good with the reactions, and that's we will work on a few problems like this, especially this one when we meet.